So integrate 1 over 4 plus x squared, but do it in two different ways for double the fun. One thing to do is look at that and say, oh, if only that 4 were a 1, because the integral of 1 over 1 plus x squared is tangent inverse. Well, that's the first way we're going to do it. So we need to somehow change this 4 to a 1, and we'll do it by factoring out a 4. So if you factor out a 4, this will become the 1. This is going to become x squared divided by 4. So factoring out is basically the same as dividing out. So we've got an x squared that gets divided by a 4. Now for simplicity's sake, I'm going to factor out that 1/4. And in order for it to look like tangent inverse, the denominator needs to look like 1 plus something is squared. Well, that something would be x over 2. So it's going to be, integral is going to be tangent inverse, but not just tangent inverse of x. It's going to be tangent inverse of x over 2. So we have the 1/4 factored out, then tangent inverse of the x over 2. There's only one small thing that's missing, and that is the derivative of the inside is 1/2. If we were taking derivatives, we would multiply by that 1/2. Since we're doing the opposite, we will divide by 1/2. And then finally reduce. If you invert and multiply this by a 2 becomes a 1/2. So it's 1/2 tangent inverse of x over 2 plus c. Okay, now do this in a completely different way. Since it happens to be in the section on trig substitution, perhaps we should try that. So set up a triangle that theta can be here. Because these two are being added together, they were the two legs of the triangle, here and here. And then I'm going to choose that this will be x and this will be 2. Then do the Pythagorean theorem to solve for hypotenuse, and it's going to be the square root of 4 plus x squared. Alright, now I need to find out what x is. So I'm going to use these two sides to find out what x equals. That would be tangent of theta. So tangent is opposite over adjacent. Just multiply by 2 to find out what x is equal to. And according to this, we need to know what dx is equal to. Oops, I jumped ahead. Excuse me. Now we need to find out what dx is equal to. So take the derivative, and we would have derivative of tangent is secant squared. The other thing I would like to find out is what is this radical equal to? So if I use this side adjacent and this side hypotenuse, well, if I do opposite over hypotenuse, that's cosine. If I switch them and have this one on top, that would be 1 over cosine, so that's secant. So just multiply by 2, and then we know what the radical is equal to. The only thing is this one doesn't have a radical, so go ahead and square both sides. Alright, now I know what to substitute for that 4 plus x squared in the denominator. It's going to be this 4 secant of theta. Now we're ready to integrate. So it's going to be integral, a 1 on the top, 4 plus x squared gets replaced with this. The dx gets replaced with this. Oh, I forgot to square when I squared both sides. I said to square both sides, but I forgot to square on the secant. Well, now look at this. There's secant squared on top and bottom. So the only thing that's left is a half. So integrate a 1/2 d theta. So that will be a 1/2 theta plus c. Finally, we need to find out what theta is equal to. Just go over here and take tangent inverse of both sides. Theta is equal to tangent inverse of x over 2. So, according to this method, the answer is 1/2 tangent inverse of x over 2 plus a constant. Compared to what we got last time, which was the exact same thing.